Good day, this is PHE 201 Biostatistics. I'll be taking you through study section 3, the law of probability, and learning to govern. When you have studied this section, you should be able to explain chance and probability, its theory and mathematical statements. You should be able to highlight and explain the rules of probability, and lastly, you should be able to describe the laws of probability. Probability is a branch of mathematics that is capable of calculating the chance or likelihood of an event taking place in percentage terms. Probability is a measure of the likeliness that an event will occur. Probability has a scientific basis, and if you have 9 likelihoods and you want to calculate the probability of one event taking place, it is said that its probability is 1/9, or the event has a 9% probability of taking place. Probability is used to quantify an attitude of mind towards some proposition of whose truth we are not certain. The proposition of interest is usually of the form, will a specific event occur? The attitude of mind is the form, how certain are we that the event will occur? The certainty we adopt can be described in terms of a numerical measure, and this number between 0 and 1, where 0 indicates impossibility and 1 indicates certainty, we call probability. Thus, the higher the probability of an event, the more certain we are that the event will occur. A simple example will be the toss of a fair coin. Since the two outcomes are deemed equiprobable, this probability of heads equals the probability of tails, and each probability is 1/2, or equivalency of 50% chance of either tail, head, or tail. Like other theories, the theory of probability is a representation of probabilistic concepts in formal terms, that is, in terms that can be considered separately from their meaning. These formal terms are manipulated by the rules of mathematics and logic, and any results are interpreted or translated back into the problem domain. There have been at least 2 successful attempts to formalize probability, namely the Kolmogorov formulation and the Cox formulation. The Kolmogorov formulation and the Cox formulation. In Kolmogorov's formulation, sets are interpreted as events and probability itself as a measure of on a class of sets. In Cox's theorem, probability is taken as a primitive, and the emphasis is on constructing a consistent assignment of probability values to propositions. In both cases, the laws of probability are the same, except for technical details. Consider an experiment that can produce a number of results. The collection of all results is called the sample space of the experiment. The power set of the sample space is formed by considering all different collections of all possible results. For example, rolling a dice can produce 6 possible results. One collection of possible results gives an odd number of dice. Thus, the subset 1, 3, 5 is an element of the power set of the sample space of the dice rolls. These collections are called events. In this case, 1, 3, and 5 is the event that the dice falls on some odd number. If the results that actually occur fall in a given event, the event is said to have occurred. A probability is a way of assigning every event a value between 0 and 1, with the requirement that the event made up of all possible results. In our example, the event 1, 2, 3, 4, 5, 6 is assigned the value of 1. To qualify as a probability, the assignment of values must satisfy the requirement that if you look at a collection of mutually exclusive events, that is, events with no common result, e.g., the event 1 and 6, 3, and 2 and 4 are all mutually exclusive. The probability that at least one of the events will occur is given by the sum of the probabilities of all the individual events. The probability of an event A is written as P into bracket A and P of A or PR of A. So you can write probability of an event by writing P, then you open a bracket, you write capital A, or you write small letter P, you open a bracket, you write capital A and close it, or you write capital letter P and small letter R, then in the bracket you put capital letter A. This mathematical definition of probability can extend to infinite sample space and even uncountable spaces using the concept of measure. The opposite or complement of an event A is the event not A. That is not A. That is the event of A not occurring. Its probability is given by P. Is given by P not then open bracket not A, and that can be written. You can use mathematical expression for that. In case when you want to write the probability of that an event A will not happen, all you need is to write P. So that shows that the event will not occur. This is the expression to show that an event A will not occur. That is to show, this shows that an event will not occur. But for the probability, as I mentioned earlier on, the probability of an event A, if you want to write it, will be in the form of P. Then you open a bracket, you write capital A as the probability of A. This is showing the probability that an event will not occur. And we have some expressions, as you can see on the slide. We have some expression for joint probability of A and B. You denote it with P into bracket A intersection B. That is the probability, the joint probability of A and B. This sign is called intersection. It's called intersection. So the probability of the joint probability of A and B is P into bracket A intersection B. A intersection B, as you have seen, as demonstrated here. And we can have interdependent event. In that case, you have this expression for interdependent. You have this expression for interdependent event. That is, event that depends on each or one another. Then, if you have mutual exclusive events, you have an expression for mutual exclusive events as the third expression. Then you can have not mutually exclusive event, which is the opposite of the mutual exclusive event. For mutually exclusive events, if A or event B or both events occur as a single performance of an experiment, this is called a union of the events A and B, and is denoted by this expression, as you can see. Then for non-mutually exclusive events, if the events are not mutually exclusive, then, for example, when drawing a single card at random from a regular deck of cards, and for conditional effect, you can see the expression probability and chance. The two terms probability and chance are closely related, and thus many get confused with this word. Chance is a word that is commonly used in everyday life situation, mostly in games of luck where chances are a particular event that take place and discussed. Chance is an everyday word used in a situation where we are talking about an event taking place, whereas probability is a precise measurement of that chance. Probability is a special branch of mathematics that helps people decide the percentage of likelihood of an event taking place, whereas chances are of an event whereas chances of an event taking place in daily life are merely opinions. A student may have a very good and bright chance of clearing an exam, or a boxer may have a very slim chance to beat his opponent in a bout. But when a weak team is playing a game of basketball against a very strong team, we say that it has only an outside chance to beat a stronger team, or that it has absolutely no chance of winning. So it can be seen that chance is a term that describes the likelihood of an event taking place. Probability as a separate field of study in mathematics originated from the study of games of chance. Tossing a coin or rolling a dice is a perfect example of games of chances. It was in the 17th century that gamblers asked famous mathematicians Blaise Pascal and Pierre de Fermat to help them in knowing their chances of winning in these games. The chances of a baby being born being a boy or girl are uncertain, but since only two outcomes are possible, it can be said that the probability or chance of a baby being a boy or a girl are equal or 50-50. In the case of dice being rolled, chances of 5 turning up a single roll of dice is 1/6, which is 16.66%. Today, help of probability is being taken in many fields such as finance, medicine, genetics, marketing, sociology, surveying, and even science to predict the outcome of an event. Exit polls in elections are the result of probability. Let's talk about odds versus probability or the differences. If you are interested in learning how to win at gambling, you need to become familiar with the concept of odds and probability. These terms can be expressed as ratios, percentages, or fractions, and each has a slightly different meaning. Probability is a general definition of probability is the likelihood that a given event will occur. When we apply concept of gambling, we usually end up with a specific expression like 1/2 or 1:2. When probability is expressed as two numbers, the first number represents the expected frequency of a specific event occurring. The second number is the total number of possible events or outcomes, including the specific event or other event that can occur. Probabilities can be expressed as two numbers in the form of a ratio. The first number represents the expected frequency of a specific outcome occurring, which is the same as with probabilities. However, unlike probabilities, the second number states only the number of all the other possible outcomes. So those are the two differences between odd versus probability. Let's move on as we talk about set theory and probability. A sample space is defined as a universal set of all possible outcomes from a given experiment. Given two events A and B, and given that these events are part of a sample space S, this sample space is represented as a set, as in the diagram in the presentation, as you can see. The law of probability. There are different laws of probability, but we are going to talk about a few of them. The law of probability can be used in games, business, and daily life. Probability measures the likelihood of an event occurring. Expressed mathematically, probability equals the number of ways a specified event can occur, divided by the total number of all possible events. There are different laws of probability. One of it is law of large numbers. You can discover the unknown probability of an event through experimentation. Using the previous example, say you do not know the probability of drawing a certain colored marble, but you know there are 3 marbles in the bag. You perform a try and draw a green marble. You perform another try and draw another green marble. At this point, you might claim that the bag contains only green marbles, but based on 2 trials, your prediction is not reliable. It is possible the bag contains only green marbles, or it could be the other 2 are red, or you selected the only green marbles sequentially. If you perform the same trial 90 times, you will probably discover you selected green marble around 66% of the total of the time. This frequency mirrors the correct probability more than accurately than the first experiment. What about laws subtraction? Probability can only range from value of 0 to 1. A probability of 0 means that there are no possible outcomes for that event. In previous example, the probability of drawing a red marble is 0. A probability of 1 means the event will occur in each and every trial. The probability of drawing either a green marble or a blue marble is 1. There are no other possibility outcomes in the bag containing 1 blue marble and 2 green ones. The probability of drawing the green marble is 2/3. This is an acceptance number because 2/3 is greater than 0 but less than 1 within the range of acceptance probability values. Knowing the probability of drawing a green marble is 2/3, and you can subtract that value from 1 and correctly determine the probability of not drawing a green marble. So there are other different other laws, but we are going to discuss only 2 of these laws in this video presentation. And I hope you will go to your material, you will learn more about these laws. I hope you have learned 1 or 2 things in this video presentation, and I hope that you will continue to learn more. See you in the next slide. Thanks for listening.